So in the last chapter, we talked about probability and how to compute a lot of probabilities, and that was because every conclusion that we make in inferential statistics is not 100% certain. There's only a degree of reliability or degree of confidence in that solution. That confidence is given by probability. And another intersection of probability with inferences that we're going to make is probability distributions. So this is like a relative frequency histogram. Remember, probability in empirical terms is relative frequency. So we want to look at these things called probability distributions that show how the values of an experiment are distributed in terms of their likelihood. So first, let's talk about random variables. So we know what a variable is, but a random variable here is just a variable here that assumes every value in the sample space of a probability experiment. So for example, if we ask 10 people, how many siblings do you have? Then the number of siblings that a person has, that is a random variable. Here's another one. A person's LDL cholesterol level. That's a random variable. Okay, if we survey a bunch of people and record their LDL, we'll get a bunch of different numbers. We can see how those are distributed. The time that it takes for a medication to clear the body. So you take a medicine, kidneys and liver clear that from the body. It takes different times for different people. A person's blood type. So that one's non-numerical. That could be a random variable. We could ask people, what's your blood type? That's our experiment, and the outcomes would be, type A, type B, type O, O negative, O positive, etc. The amount of money spent per month on gasoline. That's a numerical one. Again, we could track a bunch of people and have them keep track of how much money per month they spend on gasoline. So the outcome of that experiment would be the values of the outcomes there would be your random variable. So a discrete random variable, we know what a discrete variable is. Well, discrete random variable, same thing. You can count the values of the random variable. And then a continuous random variable is a random variable whose values are a range. They cover every range, and this is usually something that is measured. So if you've got measured values, they're usually continuous. So if we look at our example here, number of siblings that a person has, we want to know, is that discrete or is it continuous? Well, if you ask someone how many siblings they have, they're going to say, well, I have 1, or I have 2, or I have 5, for example. They're not going to say, I have 1.1. So you can count these, and there's space in between the values. Those are discrete. So you can count those values. Person's LDL cholesterol level. So, if you say, oh, my LDL is, 185, that'd be really high. Or my LDL was 90, that would be really low. Or it could actually be anything, between those values. So you could say, 90 to 185. This is usually measured in what are called milligrams per deciliter. That's your measurement there. So anything in a range, and again, this is measured, you're measuring the cholesterol, that's continuous. And then the time it takes for a medication to clear the body. So, 1 minute, 2 minutes, an hour, 3 hours, but then time is infinitely divisible. So this could actually be a range. This could be like, 4 to 8 hours, for example. And it's measured by a clock. So that's continuous. A person's blood type. So we listed some of those values. A, B, O negative, for example. This one is not continuous. In fact, this is not numerical. Okay, so discrete and continuous random variables, that's for quantitative data. Okay, this is actually qualitative data. Okay, so we're not going to be very interested in random variable of that type. This is qualitative. Might be interested in the probabilities of each one of these outcomes. And then the amount of money here that you spend per month on gasoline, so it could be, $50 or $80. It can't be anything in between because money is not infinitely divisible, but it could be just a penny more. So you could have like $80.01. Go a penny over when you're pumping your gas, fill up the truck. So this is actually discrete. You can count the number of values there because you can only divide them down to a penny. So that one is discrete. Okay, so that's discrete and continuous random variables. So now you can work Canvas homework problem, actually section 5.1. So there's some multiple choice and drop down and fill in the blank questions there, and they should be similar to what you're doing here.